Okay, problem number 13, we're going to find the distance between 2 points. For right now, I never really taught you the distance formula, though some of you have used it. What you do is you plot the 2 points. So here's -4, -3, and -8, 2. I've connected them and formed a triangle that has a right angle. We can find the sides of our right triangle simply by counting. 1, 2, 3, 4, 5. And count this way, 1, 2, 3, 4. You have to be really careful. Or you can subtract the y coordinates and the x coordinates. 2 minus a -3 would be 5. -8 plus 4, negative 4 is plus 4, gives you 4. Now you have a right triangle and you just use the Pythagorean theorem to get the longest side. So you get 5 squared plus 4 squared equals c squared. 25 plus 16 equals c squared, 41 equals c squared, and c equals the square root of 41. I didn't put plus or minus the square root of 41 because distance is always positive. So that's why we never put plus or minus here. The length always has to be positive. So that's that answer. All right, next one. We want to simplify. That's what the directions say. We have radicals in our denominator, and that's illegal, so we want to get rid of this. So we leave the big fat 3 out there. Square root of 5 over the square root of 7 minus 6 square root of 7 over the square root of 5. We're going to rationalize. I'm going to take the top and bottom by the square root of 7. That's how we get rid of the radical, because the radical times itself would free the number, because that would be the square root of 49. So we're going to get 7 down here, and this is going to be the square root of 35, and we still have this 3 out here. Same thing over here. We're going to take the top and bottom by the square root of 5. Because the square root of 5 times the square root of 5 would be the square root of 25, and that's just 5. And then we have 6 times the square root of 35. Now, since these are the same, see that dot looks confusing. Now we just find a common denominator, and we can add these together. So our common denominator is 35. So this one needs to be taken times 5, and this one taken times 7. So we get 15 square root of 35 minus 42 square root of 35. And I ran out of room. Let's just go up here. So our final answer is -27 square root of 35 over 35. Most you got that one right. Too bad. Okay, this is the killer problem in the whole test. Find the equation of the line perpendicular, this means perpendicular, to this line, which I didn't write down correctly, should be equals to, and passes through the point -2, -5. You want it to be perpendicular to this line. If the line's perpendicular to this line, its slope is the negative reciprocal of this line. First thing you have to do is take the line that they give you and find the slope. In order to find the slope, you need to put it in the form y equals mx plus b. So I'm going to get y by itself, and the number in front of the x is the slope. So we get 3 equals, there's a 1 in here, equals 1 over 3x plus 2/3. So all I did was I took this equation and I put it in the slope-intercept form. They call it the slope-intercept form because this is your slope, and this should be minus because I took it to the other side, so this is minus. Yeah, I had to subtract this. Sorry, I skipped a step. And this is your y-intercept. Now, we want an equation of a line that's perpendicular to this line. So the slope we need to use, I'll call it the perpendicular slope, is the negative reciprocal of the given line. So our slope that we're going to work with is now going to be 3. So, I think you can go from here. So you take the line and you get it into this form, you find your slope, and you flip it and change the sign. Because if you think about it, if you're going to get a line perpendicular, if this one is negative, this slope is going to be positive, so the signs have to be different. Now we have our point, which is our xy, and we have our slope. Now we have to find b. So here we go. We use y equals mx plus b, and we put in everything we know. Y is -5, m is 3, x is -2, and we just have to find b. So this is going to be -6 added to both sides, and we're going to get b equals 1. Now we have our slope, and we have our y-intercept. So we just put it in the equation. Y equals 3x plus 1 is your final answer. If you need help with these, you need to see me so we can learn how to do this. Another area that we have trouble with is graphing. I thought y'all had graphing until we did this test, and then I noticed that possibly we don't have a graph without using a chart. So, graphing, the same thing that we did in number 15, you have to get y by itself and get it in the form y equals mx plus b. Then you can look at it and say, that's my slope, and this is my y-intercept. So, first thing, you have to get the y by itself. So we're going to get 2y equals -3, whoops, these are x's. Going too fast for myself. Oh no, I'll start it. Let me just make sure I copied it right. Oops, I did copy it wrong. Alright, starting all over. 2y plus 3x equals 6. So we're isolating the y, so we get 2y equals -3x minus 6. You have to isolate it, so we get y equals -3/2 x minus 3. This is in the form y equals mx plus b. This is our slope and our y-intercept. Once you get in this form, it should be really easy for you to graph these. Make sure I got it in the right form. Okay. You start with b, because b comes before m. Our y-intercept is -3. So that's where it crosses the y-axis. So I go down 1, 2, 3 and put a point. Starting at that point, our slope is -3/2. Remember, m comes before the x. This is our slope. Slope is rise over run. We start at our b and we rise 3, which means we fall 3. So 1, 2, 3, and we run 2. 1, 2. And down 3/2. And then we have our line. We just connect our 2 points. And we have a nice line. You notice the slope is negative. It's going downhill from left to right. And our slope is negative here. It crosses the y-axis at -3. If you do not know how to graph this way, please see me and we have to get this taken care of.